Hello, everyone, and welcome to Group 7's presentation on Chapter 9, titled Create the Foundations of Our Deployment Pipeline. In order to create fast and reliable flow from development to operations, we must ensure we always use production-like environments at every stage of the value stream. We need to enable environments to operate on an automated manner and ideally demand from scripts and configuration information stored in version control, while being entirely self-serviced without any manual work required from operations. Our collective goal is to ensure that we can recreate the entire production environment based on what's in version control. We need to detect problems before they hit the deployment stage so that any adverse effects will not affect the customer. The Enterprise Data Warehouse program led by M. Campbell Preedy in 2009 is an example where a spectrum of problems can be addressed and solved efficiently. A quote from Campbell Preedy in 2014, she says, "At the time, there were 10 streams of work in progress, all using waterfall processes, and all 10 streams were significantly behind schedule. Only one of the 10 streams had successfully reached user acceptance testing, or UAT, on schedule, and it took another 6 months for that stream to complete UAT, with the resulting capability falling well short of business expectations. This underperformance was the main catalyst for the department's Agile transformation. However, after using Agile for a year, they only noticed small improvements. Instead, they decided to create new integration and build a team that was responsible for building quality into our processes instead of trying to inspect quality after the fact. In each environment, they had goals to keep fixing forward, but they neglected the fact that changes needed to be made in version control. Once realized, they fixed the version control, and deployment time was reduced from 8 weeks to just 1 day. Campbell Preedy's story shows how a variety of problems can be traced back in inconsistently constructed environments and changes not being put back into version control. One of the first times we can see catastrophe is the first time we see how our application behaves in a production-like environment. In many cases, dev teams may request test environments in the earlier stages of the project. However, when there are long lead times, testing may be cut in favor of saving time. But even with testing, there can be misconfigured environments that also result in a failure. We as developers tend to run testing on their own workstations. This way, developers can run and test their environments as part of their daily work. We should also create a wiki page for the specifications of the production environment. That way, everyone such as development, testing, and production can have access to production-like environments in minutes. Continuing on, instead of operations manually building and configuring the environment, we can use automation for any or all of the following. Copying a virtualized environment, think of VMware images or booting an Amazon machine image file. Building an automated environment creation process that starts from bare metal, using infrastructure as code configuration management tools, using automated operating system configuration tools like Solaris Jumpstart or Debian Preseed, assembling an environment from a set of virtual images or containers, and lastly, spinning up a new environment in a public cloud such as Amazon Web Services. Because we've defined all aspects of the environment ahead of time, we are not only able to create new environments quickly, but also ensure that these environments will be stable, reliable, consistent, and secure, in turn benefiting everyone.
Okay, now as a developing team, things need to be collaborated on a single system, which is why in the recent decade there's been a mandatory use of what's called a version control system, which is a system that is able to commit, compare, merge, and restore any past revisions of coding and stuff. Uh, Perfect example that's popular to use for a version control system is GitHub.com. It it is designed so that all developers from around the globe can access other people's coding data and then can share that with other developers. But once the teams collaborate and then they develop their coding, they put it all together in a singularity known as the repository of truth. And the repository of truth is the main code of everything that's been worked on. And there are certain assets that need to be in this repository, which includes all the application coding and dependencies that the developers made, any scripts that were used to create the schemas and data, all of the environmental creation tools that were used to make it in the first place, any files that were used to create containers, all of the supporting automated tests, any of the scripts used to support the code, all the project artifacts that were used in it, all the cloud configuration files, and any other script required to create the infrastructure. So, in a sense, everything and anything that was used to create to develop a project goes into this repository. Nothing gets left out. Now, in order to make the infrastructure easier to rebuild than to repair, there are most cases where if something bad to occur, such as elect electronic damages or like natural disasters such as earthquakes, tornadoes, firestorms, all of that. If something were to happen to the physical devices, then they would either have to be rebuild brand new if the repair cost is too much, and then the system needs to be set up in a way that is able to handle more added servers later on, which is called horizontal scaling. And whenever whenever down the pipeline, like a change has been made into the production, everyone else needs to know about that production change. There shouldn't be any secrecies, otherwise it'll get messed up in the end result because of because without that notification, then like how can everyone else know about it? Another way to make it easier rebuilding is using the automated configuration systems. Like these systems were designed to do all of the setup just so that the developers or the IT administrators don't have to manually set up the system every time something fails. This sort of automation and these practices can help reduce the ways that the infrastructure can drift from its known good states, and it will also keep the pre-production environments up to date. If the system is not set up to date, or if it's set up poorly, to which it makes it a lot harder to upgrade, then then there needs to be a better infrastructure for it to handle any sort of scalings or fail safes.
So now that our environments can be created on demand and everything is checked in version control, our goal is going to be ensuring that these environments are being used in the daily work of development. We need to verify that our application runs as expected in a production-like environment long before the end of the project or before our first production deployment. Modern software development uses short iterative development intervals as opposed to models such as the waterfall design. As a general rule, when the time between deployment increases, the outcomes are much, much worse. Part of this process is the routine integration of code into production-like environments at increasingly frequent intervals throughout the project. The definition of done goes beyond just having code that works. At the end of each development timeline, we have integrated, tested, working, and shippable code produced in a production-like environment, meaning the loads of the software experiences are as close to or at production-like. This prevents situations when a feature is marked as done because a dev is able to run it successfully on their laptop. So now on to the next slide. As developers write, test, and run their code in their production environments, we're able to integrate all this into daily work as opposed to the end of the release cycle. Ideally, through having all the tests automated, our application will have ran correctly in a production-like environment many, many times, potentially having our software ran hundreds or thousands of times, which gives us confidence that most problems have been found and fixed. Ideally, we've been using the same tools for monitoring, logging, and deployment in pre-production as we will in the actual production. Since we've been doing this, it'll give us a sense of familiarity with the tools, as well as experience with them, which helps us greatly and efficiently give us a smoother deployment of our service. All of this put together greatly helps us keep the risks involved to a minimum with our deployment. So then on to the conclusion. The fast flow of work from developers to operations requires anyone to get production-like environments on demand. The use of production-like environments early on significantly reduces the risks of problems later. As we put all production artifacts into version control, we end up with a single source of truth. This allows us to recreate the entire production environment in a quick, repeatable way. And as we make infrastructure easier to rebuild than repair, problem solving gets easier and faster, as well as having expanded capacity. Yeah, thanks for watching.